A lot of things to remember on my end. Turn the recording off during break, turn the recording back on, answer your chats and emails. So I'm working hard here on and sitting in front of my screen here. So again, when we divide fractions, we're going to change all mixed numbers to improper fractions. And then we're going to invert or turn upside down the divisor and then multiply the two things together. So let's see what that looks like here. And this is on page 22 of the textbook. So we want to divide 5 1/4 by 1 1/2. So we're going to change all mixed numbers to improper fractions. So 5 1/4 is 4 times 5 is 20 plus 1 is 21. So 5 1/4 is 21/4. 1 1/2, again, 1 times 2 is 2 plus 1 is 3. So 3/2. 1 1/2 is the same as 3/2. So in this case, we have 21/4 divided by 3/2. It says to invert the divisor, right? Invert meaning turn that thing upside down, make the 3/2 into 2/3, and multiply everything together, right? We do that. 21 times 2 is 42. 4 times 3 is 12. And then we can simplify that 42 12s. Right, 12 goes into 42 3 times. 3 times 12 is 36. So we have 36 minus 42 is 6 left over. So we would have 3 6 12s. And 6 12s is the same as 1/2. So the result is 3 1/2. Does everyone see A, how I did that, and B, how I simplified the 42 12ths into 3 1/2? Okay.
Wait, Mr. Becker, how'd you get the half again?
I have a result of 42 12ths. Right, 42 12ths is an improper fraction. The 42 in the numerator is bigger than the 12 in the denominator, right? So I could do it one of two ways. Since 42 is a even number, I could divide top and bottom by 2 and get 21/6. I could do it that way, but the way that I did it before is, right, 3 times 12 is, well, let's do it this way. Divide 42 by 12, and I end up with 3 and some stuff left over. So I have 3 times 12 is 36. So I know I have at least 3 times 12 and 42 of them. And 42 minus 36 is 6. So I have 3 and 6 12ths. 6 12ths is the same as saying 1/2, right? Because 2 times 6 is 12. Again, these things are going to take practice. If this is something that you haven't done in a long time, it's going to take some practice. This is one of those things where the light bulb may go off and you may say, oh yeah, it makes sense. Or you may have to work some problems, right? I went to engineering school in college, and I spent a lot of time in the library my freshman and sophomore year doing problems, right? That's how I became conversant at lots of things, is by doing problems. So in the textbook, you have lots of practice problems that you can work on. Again, I would do practice problems until it starts to make sense to you. Did I answer your question? I sorry, I didn't see who asked that a minute ago. How do
Yeah, thank you.
you get 42 12s into 3.5? Okay. We don't generally do it. We don't always do it, but we can convert those fractions into decimals, right? Anything that's in tenths or hundredths, we could write as decimals. So 3/10 is the same as 0.3, and 87/100 is the same as 0.87. So 3/10 or 87/100. And the whole numbers are on the left side of the decimal point. So sometimes we'll be working with decimals. More often than not, we'll be working with fractions. Again, certain people in the construction industry, or certainly in manufacturing, you work with hundreds and thousands, right? You might have tolerances to the thousandths of an inch. So you might be measuring in hundreds and thousands. That's generally not what we do in field construction, right? We're probably doing pretty well if we get everything to the closest eighth of an inch when we're out in the field doing stuff. In this case, dividing decimals, this is stuff that you can do with the calculator on your phone. So if they're whole numbers and you're dividing them, or if they're decimal numbers and you're multiplying and dividing them, or adding and subtracting them, I mean, we can go through this, but I think this is just as easy to pull out your phone or your calculator. It's just that your calculator on your phone probably doesn't handle fractions, doesn't handle improper fractions or mixed numbers, which is why you got to do it either in your head if you're good, or do it with the pencil and a paper. 26 by 4, 26 divided by 4 is something that you could certainly do on your phone, or you could do it the longhand way that I learned how to do, because I'm old enough to remember doing this stuff before calculators and smartphones arrived. So that's the way we had to do stuff. So 26 divided by 4 is 6.5. If we are adding and subtracting decimal numbers, right, this is on page 23 of the textbook if you're there, right, they're added and subtracted like whole numbers. We just have to make sure that we line all the decimal points up. Right, so it's easier if you do this and line everything up so the decimal points all line up, and then go down and add stuff up, either with your calculator or in your head, right? So over here in I remember this is tenths, hundredths, thousands, 10,000s. Over in the 10,000s place, nothing else is there, so that 5 drops right down. 2 plus 5 plus 5 equals 12, so 2 carry the 1. So there's a 1 up here now. 1 plus 1 equals 2, plus 5 equals 7. 14, 16. right? 6, carry the 1, 5, 6, 12, 15. Put a 5 down there, carry the 1, 9, and 3 is 12. Or you can do that on the calculator on your phone. But again, you might be in a situation where you got a pencil and a paper, and you don't have a tool handy. You have to remember how to add and subtract numbers. So again, when you're adding and subtracting decimals, you line all the decimal points up. Right, subtraction is the same way. Line the places up, whole numbers, tenths, hundredths, thousands, and subtract. Right, multiplying decimals, again, you can do it on your calculator on your phone, but the rules are, right, they're multiplied the same way as we handle whole numbers. Don't worry about the decimal points. And then when everything is done, how many decimal point places were there in all the numbers that were multiplied together? And then put that number of decimal places back into the answer, starting from the right. So again, 6.25 times 1.5, right? Multiply those numbers together, either by longhand or by the calculator. And then when you're done, you see that we have 3 decimal places, 1, 2, 3. So in our resulting answer, we count over 1, 2, 3, and we put the decimal point right there. Right. This one is a little hard to explain, so I'm going to let you look at it on page 24 of the textbook, because this gives a better explanation than what I have on my slides. Again, 26 divided by 6.5 is the same as 260 divided by 65, and the result is 4. Again, this is something that you can do probably just as easily on your calculator on your phone than do by hand. Another example, I haven't done longhand division in quite some time, so I'd be a little rusty at this. Right, if we're adding and subtracting feet and inches, we're going to consider the feet and the inches separately from each other. The inches would be inclusive of the fractions if they are there. Right, so 12'3" minus 9'1" is 3 feet 2 inches. Right, we subtracted the 3 from we subtracted 1 inch from the 3 inches to get 2 inches. We subtracted 9 inches from the 9 feet from the 12 feet to get 3 feet. You're likely to have somewhere in reference materials that you might have would be the conversions from inches to decimal values. Right, so half an inch is the same as 0.5. A quarter is the same as 0.25. Again, certain things you may need to do the math this way. Let's talk about applying some of these things, right? Moving now from a single dimension into 2 or 3 dimensions, right? Area equals length times width. And we just have to make sure that we are multiplying things that are in the same units. Right, so if we have a room that's 12 feet 5 inches by 76 inches, right, we either have to convert the 12 foot 5 into inches or the 76 into feet and inches. Probably the easiest thing to do would be to convert the 12 feet 5 into inches, right? Each foot has 12 inches, so 12 times 12 is 144 plus 5 is 149. So 12 foot 5 is the same as 149 inches. So 76 inches times 149 inches is 11,324 square inches. But most times we're not reckoning things in square inches, we're doing it in square feet. So we have to divide that by 144. 144 is a conversion between square inches and square feet. So 11,324 divided by 144 is 78.64 square feet. We would come, right? Does that make sense?
Yeah.
We could do the same thing by converting these to feet and decimals, right? Which we might be doing on the next screen. Let's take a look. Correct, we can convert that to decimals. So 12 foot 3 inches is the same as 12.25 feet. 10 feet 6 inches is the same as 10.5 feet. And we do the multiplication and we come up with a result in square feet. Again, how do we convert from inches to decimals? Right, the ones that they gave you there were easy, but you can, again, you either memorize this stuff or you look it up in a table. Right, the easy ones obviously are half an inch equals 0.5, a quarter is 0.25. Right, I wouldn't necessarily remember that 11/16 is 0.6875, but you might memorize that depending on the kind of work that you do. Right, so if we are multiplying to get areas, we can either do it in inches and convert and divide by 144 to get it back into square feet, or we can convert the feet and inches to decimals, do the math, and we get square feet directly. Triangular area is base time height, or 1/2 base time height, or base time height divided by 2. So the area of a triangular piece of something that's 24 foot by 5 foot would be 5 times 24 divided by 2, or 60 square feet. If we're dealing with something that is circular, first of all, we have a couple definitions. Circumference is that distance around the outside of the circle. The diameter is the length of the line that bisects the circle or goes through the center of the circle, all the way through from one side to the other. The radius is half the length of the diameter. Pi, or the Greek letter pi is the is the magic thing that you use to convert diameter and radius into circumference, area, or volume, right? And pi 3.1416, they say. I usually think of it as 1415, but let's see how these calculations go. But again, circumference is the area all the way around the circle. That's pi times the diameter. And the area of the circle, right, that would be the area of all this stuff in the middle. That's pi times the radius squared. R squared would be pi times radius times radius. Right, circumference equals pi times diameter. So what's the circumference of a circle that has a diameter of 6 foot 6 inches, right? We converted the 6 foot 6 into decimals, 6.5, so 3.14, which is pi times 6.5, is 20.42 square feet. And we find the circumference of an arc. Arc is a portion of that circumference. So we have, what is a circumference that has a radius of, and let's see, I'm on page 27 of the textbook. We're almost there. And our time is running short as well, right? Radius is 4 foot 3 inches and an arc is 90 degrees. So first we're going to find the circumference. Then we're going to find out what portion of the whole circle or the whole circumference that arc of 90 degrees is. Right, so circumference is, remember, 4 foot 3 inches, or 4 1/4 is the radius. The diameter is 2 times the radius. So diameter times pi is the circumference. Remember the units that we're in, right? We're in feet, so that would be a circumference of 26.7 feet, right? In all of our math problems, there's always going to be a unit, so we have to remember whether we are in feet or in inches or something else, square feet, square inches, right? The entire circle is 360 degrees, so 90 degrees is a quarter of that circle, right? So divide the 26.7 by 4, and you get 6.68, or 6 foot 8 inches. Again, you would need to use your little table of decimals to inches, or decimals to inches, to convert the 0.68 back to 8 inches. Right, that's on the table, figure 2.2 on the bottom of page 25. Right, circular area, pi times r squared, not pi times diameter, which would be radius times 2, but it's r squared, which is radius times radius. So what is the area of the patio that has a diameter of 30 feet? Diameter is 30, so the radius is 15, right? Radius is half of diameter. So area equals pi times radius squared. So pi times 15 squared. Squared is the same as multiplying the number by itself. So 15 times 15 is 225. times pi is, right, just a smidge under 707 square feet would be the area of a patio that has a diameter of 30 feet. Volume, again, if you're pouring concrete, you're probably going to be concerned with volume, right? If you're doing sheet goods or flooring or that sort of thing, you're probably concerned with area, how big something is. If you're pouring concrete, you're going to be concerned with volume, right? So volume is now in 3 dimensions. So it's going to be, instead of being in square feet or square inches, it's going to be in cubic feet or cubic yards. Because oftentimes concrete and aggregate and things of that nature are in cubic yards. Right, so we just had a patio with an area of 706 square feet. That was our previous problem. Right, so if we wanted to have a 4-inch thick patio of that area, right, how much concrete do we need? Right, so 4 inches thick, 4 divided by 12 is 0.333. So multiply those together, we get so many cubic feet. And if we want to convert cubic feet to cubic yards, we divide by 27. How do we get 27? Well, there's 3 foot in a yard. So 3 times 3 times 3 is 27. So that's 27 is a conversion from cubic feet to cubic yards, just like 144 is a conversion from square inches to square feet. And does anybody have any questions? I've gotten to the end of the presentation. I was thinking we might break up and have you work on stuff, but it looks like we are running short on time here. Any questions?
Mr. Becker, would you be able to post the answers at some point before next week, the answers for activity 2-1?
Yeah, I think what we'll do is I will go through them. I'm a little reluctant to post stuff because as soon as I post stuff, then everyone in the whole world is going to know the answer, right? So I think it's probably easier that I'll set aside some time at the end of class on Thursday, and we'll go through activity 2.1 and talk through the problems that we're vexing, and I'll make sure that your answer is correct. Right, because again, if the answers start floating around out there, then no one's ever going to want to do the hard work of doing the work. They're just going to find the answer key. So I'm a little reluctant to give that out, if you understand.
Could I ask a quick question about the architect? I forgot what it's called, but it was on our course materials list. It's like the ruler for architects, but that's not the correct term.
Yes, it's a architectural scale. Yes,
Yes.
that is correct.
Do you have a certain one that you recommend, or can we just get any one?
I will find a recommendation and send it out to you. I mean, I was going to say, do I have one? I'm looking around my room to see if I have a scale. I don't have one handy, but I will make a recommendation for you, Nicole.
All right, thank you.
Right, if you're a tradesperson in the field, your tool is generally going to be a measuring tape, which I do happen to have. Right, a measuring tape is right? The one that I have in front of me here, it's in 16ths of an inch, right? So I can measure stuff to the 16th of an inch. So if you're a tradesperson in the field, your tool will generally be a measuring tape or a carpenter's rule. If you're a or some variation thereof. If you're an architect in the office, then your tool will probably be the architectural scale, because you'll be scaling things off of a drawing. If you're if you happen to be the estimator, right? If you're the person that has to take off a set of drawings to determine quantities or lengths, you'll probably have that architectural scale as well. So depending on where you fit into the construction industry, you'll have different sorts of tools. But yes, Nicole, I will make some recommendations for you.
Thank you.
Well, you're very welcome. Any other questions? First of all, did everyone other than Josue and Pablo, who joined the class this week, did everyone else complete the quiz that was on Blackboard? I was trying to jump back and forth. I think I asked a question of one of you in the chat. The chats are coming in faster. Okay, I'm gonna take that everybody did. If for some reason I'm missing you, I will send out an email. I thought when I eyeballed the numbers, there was one of you missing. I think that person, I believe I sent you a message in the chat asking about that. So hopefully you have taken care of that. Okay, so yes, Ayana.
Good evening. I just wanted to know, what is the next assignment that we will be turning into Blackboard?
This particular week, there is nothing that you're going to turn into Blackboard.
Okay.
So you turned in hopefully you turned in your building codes and permits assignment into Blackboard from last week. There is nothing in this week, week number 2, that you will turn into Blackboard. Hopefully, though, you will do, depending on your proficiency with fractions, you'll work on practice problems, and then hopefully you'll work on the activity where they're trying to take this stuff in feet and inches and fractions and turn it into more concrete examples of the sorts of problems that you'll face in the field. So, and then on Thursday we will also be doing unit number 3, which is basically reading and interpreting the tools we just talked about, the tape measure and the carpenter's rule and the architectural scale. Right, especially the architectural scale, again, getting conversant with those tools. And I actually have a bunch of videos posted that I have to sort through, and I will find ones that I would recommend you watch if you need more practice. Any other questions? Again, I think Josue and Pablo, if you want to hang around for a couple minutes, we'll figure out some mechanics here at getting you guys up to speed. And the rest of you, I will let you work on activity 2.1. We will check in on that briefly at the top of class on Thursday.